Okay, so we've been talking about this arctangent function. Before I go any further, I just want to mention this -1 doesn't have anything to do with like 1 over x or anything like that. It's not about multiplicative inverse. It's the inverse of a function. There's actually a tangent function that acts kind of like in the opposite direction here. So like the tangent of pi over 4 would be 1. But that's the kind of inverse that they're talking about. Oh, and one other thing too, I was just looking it up. This thing that I had down as the Gregory series, it turns out that there's this guy, Madhava, from India, who's an Indian scholar, who found this series more than 200 years before Gregory. So I just changed my slide to Madhava series. So this came, so this guy, like I said, this was around 1400, sometime like that. So the ancient Greeks didn't, had tables related to the arctangent, but they didn't have this infinite series. So this is actually, and this is Madhava had this arctangent series, and also the sine and cosine series for the sine and cosine that we'll see in a little bit too. But anyhow, so we have this cool relationship where this arctan of 1 equals pi over 4. It's also the case that once we put together this function with all these powers and stuff in it, we can do some other cool stuff with this function. If we look at this graph, so here's a line with 2 points on it, x1, y1, and x2, y2. And if we let delta x equal this distance from x1 to y2, so x2 minus x1 is this distance, right? So that's our delta x. And then y2 minus y1 is this distance, that's our delta y. So if we take delta y over delta x, that's the slope of this line, right? If we take the arctangent of that, what we get is this value theta. So if you haven't seen this notation before, a lot of times for this measurement, Greek letters will be used. So right now I'm going to refer to this theta as an arc length, because we can relate it to this arc length that we've seen over here, where if we know that the radius is 1, then we can relate this arc length, this distance from here to here, to this angle. So the tangent, the arctangent of the slope gives us that special unit arc. So if we know that this is the length 1, then it'll give us this arc length. So let's see. Oh, so yeah. So now, going from 1400 to today, we now have these functions in the Java library, math.atan and math.atan2. Math.atan takes a parameter that's a double, and returns a value in the range minus pi over 2 to pi over 2. So what do I mean by that? Well, if we think of the circle, actually if we know that this radius r is 1, then 2 pi r, the circumference of the circle, is just going to be 2 pi, right? If r is 1. 2 times pi times 1 is 2 pi. So then going from here to here is going to give us pi over 2, right? And then all the way over here gets us to pi. And if we think about a negative direction, let me show you on here. So if I click over, the closer I get to a 180-degree angle, the closer this length should be to pi, right? If the whole circle is 2 pi, then half a circle should be pi. So let's see if I can get how close I can get to. Oops, it's flipping around. So now I'm at 178 degrees. I'm getting a little closer to pi there. And I go down a little bit. Oh, yeah, that's pretty close. So 180, right? And this is a pretty close approximation of pi, right? So you notice that the circle flipped around when I went down here. So what's happening down here is we're getting, so up here we had the range from 0 to pi, and down here we have the range from 0 to minus pi. So now we're getting into our minus number. So if I go down here, like if I go, can I get to, the closer I get to minus 90 degrees, that's kind of close. So this arc length is about half of pi, but it's in a negative direction, so we call it, we say negative, right? So so this atan can give you numbers in this range. So, and when you think about it, so this slope here, remember we were talking about the change in y over the change in x for our slope. Since we have one point is the origin and one point is AB, the slope of this line is just, we can just say b minus 0 over a minus 0, or just b over a, right? The problem is that, so if we said give me the arctangent of a over b, it should give me this theta, right? The problem is, on b over a, I mean, the problem is that b over a is the same, gives us the same value as minus b over minus a, right? A negative over negative is a positive. So we don't have an unambiguous way to decide, should I give you this theta or the theta that goes all the way around here to minus a minus b. So what we do is for atan, we just restrict the range to minus pi over 2 to pi over 2. So we just say we're just going to look at this half of the circle. But with atan 2, what we can do is, since we're giving both, we're giving the y and the x. So we're giving, so this would be our b and this would be our a. We can, because we're giving both, we can tell which quadrant we're in. We can tell. So if we gave a negative b, negative a here, we would know we're down here. So we want this angle, or actually what we would get would be this one, right? So if we're below the x-axis, we're going to get a negative angle. So we're going to go from the x-axis in a negative direction to that way. So we would get, so with atan 2, we can get points on the whole circle. So we can get the range from minus pi. So, you know, from 0 to minus pi, and from, or basically from minus pi all the way around to pi, how we want to say it. So we get the whole circle.